This video is about the determinant of a square matrix. In this lesson, we'll calculate the determinant of a 2 by 2 matrix and the determinant of a 3 by 3 matrix. A determinant is a real number that's calculated from the entries of a matrix. And this number, called the determinant, is used in many applications of matrices. First, let's discuss how to find the determinant of a 2 by 2 square matrix. Here is an example 2 by 2 matrix. To find the determinant of this matrix, we need to have notation that tells us we want the determinant. If this matrix was labeled matrix A, then one way to say that you want the determinant of matrix A is to write det A. Another way to indicate that we want to find the determinant of matrix A is to write vertical lines around the capital A. When working with matrices, these vertical lines are not absolute value bars. They mean determinant. If we don't want to refer to the matrix with a capital letter, but instead we want to actually indicate the entries in the matrix, then the determinant is again written with vertical lines, but the vertical lines surround the entries. This notation with brackets indicates a matrix containing the numbers 1, 3, 4, and 6. This notation with vertical lines indicates the determinant of the matrix containing 1, 3, 4, and 6, and this is equal to a real number. So let's discuss how to find the determinant of this 2 by 2 matrix. It involves multiplication and subtraction. Multiply this diagonal together, 1 times 6. Then subtract the product of this diagonal, 3 times 4. And work out this answer. 6 subtract 12 is equal to -6. The determinant of the matrix containing 1, 3, 4, 6 is -6. In the previous lesson, when we were finding the inverse of a 2 by 2 matrix, we also multiplied these two entries together and subtracted the product of these two entries. We did that in the denominator of the formula that we used to find the inverse of a 2 by 2. So that was one application of determinant of a 2 by 2 matrix. Let's try another example. Let's say we want to find the determinant of the matrix containing these numbers. I know that this means to find the determinant of the matrix because of the vertical lines. Multiply diagonally, -2 times 8, that's -16. And then subtract and multiply the other diagonal, 5 times 3, which is 15. And then figure out this answer, -31. So in general, if you want to find the determinant of a matrix that contains A, B, C, and D, you multiply A times D and then subtract B times C. This is your formula to find the determinant of any 2 by 2 matrix. Next, let's find the determinant of a 3 by 3 matrix. There are different methods that you can use to do this. One method is called expansion by minors. Let's take a look at this method. And we'll use this 3 by 3 matrix as our example. We know we want to find the determinant because of the vertical lines around the numbers, not brackets. Here's how the expansion by minors process works. The first thing you do is you choose any row or column that you would like to use. I'm going to choose row 1, but I don't have to choose row 1. I could use row 2 or row 3, or I could use column 1, column 2, or column 3. The next thing you do is you take the first entry from the row or column that you selected, in this case, the 4. Then we're going to multiply that by a 2 by 2 determinant that contains 4 numbers. And the 4 numbers that we put in there are the numbers that are not in the same row as the 4, and they're not in the same column as the 4. That is, this set of 4 numbers, 3, 5, 6, 3. Next, we're going to have a subtraction sign. And then choose the next entry from the row that we're choosing to focus our attention on. The next number is a 6. And multiply that by the determinant of a 2 by 2 matrix. The 4 numbers in this determinant are the numbers that are not in the same row as the 6, and they're not in the same column as the 6. They're these two and these two. So 2, 5, -1, and 3. Next, we're going to use a plus sign. Any guesses what number will go here? It's going to be the 1 times a 2 by 2 determinant. And the 4 numbers in that determinant are the numbers that are not in the same row or same column as the 1. The 2, 3, -1, and 6. Now let's evaluate this. We have 4 times, and we're going to evaluate this 2 by 2 determinant. 3 times 3 is 9, minus 5 times 6 is 30. Now subtract 6 times. 2 times 3 is 6, minus 5 times -1 is -5. Now plus 1 times 2 times 6 is 12, minus 3 times -1 is -3. Simplifying, this is 4 times -21, then minus 6 times 11, then plus 1 times 15. Type this in the calculator to get the answer. The result is -135. The determinant of this 3 by 3 matrix is the number -135. I found that determinant by expanding by minors using the first row as my focus. The number 4 is written here. The number 6 is written here, but there's a minus sign in front of it. And the number 1 is written here, but with a plus sign. So not only am I using the numbers from the row and creating determinants using the other numbers, but I'm also following a pattern with plus and minus signs. A plus sign here, a minus sign here, a plus sign here. I said that you can do the expansion by minors technique using any row or any column. If we hadn't used row 1, then we need to make sure we're using the correct pattern of signs for whatever row or column we're doing. So let's make a key for the pattern of signs. It looks like this. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Notice the diamond arrangement of negative signs. If we were going to use row 2 to expand by minors, when you write down the numbers from row 2, you're starting with a negative, then having a plus sign in the middle, and then having a negative. Let's redo the problem and use row 2 as our focus row. Here we go. We begin with a negative from our pattern, and then the number 2. That gets multiplied by a 2 by 2 determinant, where the numbers are not in the second row or in the same column as the 2. So the numbers would be the 6, the 1, the 6, the 3. Now a plus sign from right here. And the next number in row 2 is a 3. That gets multiplied by a 2 by 2 determinant. Not using the numbers from row 2 or from column 2. So it's 4, 1, -1, and 3. Now our key says to go to a negative sign. And then the next number in row 2 is the 5. That gets multiplied by a 2 by 2 determinant. Now what are the numbers that are in that determinant? Don't use the numbers from row 2 or from the last column where the 5 is. So it's 4, 6, -1, and 6. Now we'll evaluate this. -2 times 6 times 3 is 18, subtract 6. That makes 12. Now this determinant, 4 times 3 is 12, subtract -1. That makes 13. And now that last determinant, 4 times 6 is 24, subtract -6. That makes a 30. When you type this in the calculator, this is -135. You can also expand by minors using columns as your focus. Just make sure you're following the pattern of signs from our key. Let's do another example and find the determinant of this 3 by 3 matrix. If you use expansion by minors as the process, then you can choose any row or column of numbers to use as your focus. The work will be easiest if you have any rows or columns that have zeros. The first column has a 0, the second column has a 0, the third row has 2 zeros. The easiest one to use is row 3. Let me scroll up just a little so we can see our key telling us the pattern of plus and minus signs. For row 3, the pattern is plus, minus, plus. Look what happens though if you use row 3. You start with 0 and you multiply it by a 2 by 2 determinant using the numbers 3, 4, 5, and -2. Then our key says to start with a minus sign, but the next entry is also a 0. And that will get multiplied by a 2 by 2 determinant. Not using these numbers or these numbers, it's the 2, 4, 6, and -2. Then our key says to use a plus sign, and the last number is a 3. And that gets multiplied by a 2 by 2 determinant. Don't use numbers from here or here, so you're left with the 2, 3, 6, and 5. Notice how 0 times whatever this number is just going to be 0. And here in the middle, 0 times whatever this number is just going to be a 0. So we're left with 3 times, and then 2 times 5 is 10. Subtract 3 times 6 is 18. 10 subtract 18 is -8. This answer is -24. The fact that the third row contained some zeros meant that we didn't even have to do this part or this part if we had recognized we only would have this last portion. And we can get the determinant very fast for a 3 by 3 if there are some zeros in the matrix. Next, I want to demonstrate method 2 for finding the determinant of a 3 by 3 matrix. And then once you see both methods, you can decide, do you want to expand by minors or do you want to do diagonals method? Let's make an example 3 by 3 determinant. I'm just filling in some random numbers. You could even put a 0 in there to save some time. Here's how diagonals method works. Rewrite the first column of numbers to the right of the bar. 3, 1, 4. Then rewrite the second column of numbers to the right of those. 2, 0, and 6. Don't rewrite the third column. Diagonals method works a lot like the 2 by 2 method, where you multiply diagonally, and then when you multiply diagonally in that downward left direction, you have a subtraction in front of it. Here's what I mean. Our first diagonal, 3 times 0 times -8, makes 0. Now we're going to add. Now the next diagonal, 2 times -2 times 4. That's -16. Now we're going to add in our third diagonal, which goes down to the right, 5 times 1 times 6. That's 30. Now we're going to start subtracting diagonals. So subtract. Here's our first one. 5 times 0 times 4. That's a 0. Now subtract again. 3 times negative 2 times 6. That's negative 36. Finally, we're going to subtract one more diagonal. 2 times 1 times negative 8. That's negative 16. Figure out this answer. Be really careful with the whole subtracting negatives right there. So we have negative 16 plus 30 plus 36 plus 16. You can type this in the calculator or just do it by hand. Negative 16 and plus 16 cancel. It looks like the answer is 66. If you do expansion by minors with any row or any column, you will also get 66. So I'll leave it to you to decide which method you like better, expansion by minors or diagonals method. This concludes the video about finding the determinant of a square matrix.